Okay, so today we're going to be working on finding zeros of different polynomials. We're going to do a couple of examples together, just some different things you might run into. So we've got x to the fourth minus 64. So we are expecting up to 4 zeros. Our first step is always going to be to graph, see if we can get some of the zeros that way. If I go to the graph, I do see 2 of the zeros, okay, and they're both linear, which means they only count as 1. So that means there's also 2 imaginary zeros because we need to have a total of 4. And these look like decimals that have been rounded. So these aren't even good answers here. I can use this to check, but I'm going to have to find everything by factoring. So I tried graphing. Okay, I got an idea from the graph, but that's not going to help me too much since I have no real rational zeros, no integer zeros that I can use. I can't really divide, and I can't solve for x here. I'm going to try to factor. Okay, I can use difference of squares on this. Okay, x to the fourth and 64 are both perfect squares. So I'm going to use difference of squares here to help simplify. So x to the fourth is just x squared squared. And 64 is just 8 squared. So we can rewrite this as x squared plus 8 and x squared minus 8. Now we've done the factoring. We're going to go back. We're going to solve for x. We don't need to use the quadratic formula here. I've got this down to 2 factors. And what I can do is set each of these factors equal to 0, and I can just solve for x. Now, normally when we've got an x squared, we can't solve for x because we maybe have an x as well, but we've just got a single x squared here. So we can solve. I'll show you how. We would just subtract 8 from both sides. So we get x squared equals negative 8. And since we're down to just one x, we can square root both sides. So we get x equals plus or minus the square root of negative 8. We do the same thing over here, and we'll simplify that in a minute. And we get x squared equals 8. Square root both sides, and we get x equals plus or minus the square root of 8. Well, guess what the square root of 8 is? Square root of 8 is approximately 2.828. So that's why we see those zeros there. But we also have some imaginaries of those with this negative in here. So we can simplify this to be plus or minus I times the square root of 8. And I would accept these as your 4 answers. But just as an FYI, we can simplify that square root just a little bit. The square root of 8 is equal to the square root of 4 times the square root of 2, right? And square root of 4 we can do 2 root 2. So my answer could also be written as plus or minus the square root 2 times the square root of 2. Or plus or minus 2i times the square root of 2. Just another way to write the answer, but like I said, I would accept the square root of 8. That's fine. Let's do another example. Okay, this one's a little bit more straightforward. We can't factor this because it has 5 terms and we don't know how to factor something with 5 terms. So hopefully we can get some information from the graph. So let's go to the graph of this one. Okay, excellent. I see 2 zeros. Great, and they're both integers, negative 4 and 1. So I'm going to use those. So I've got 2 of my answers already. So from graphing it, we got negative 4 and 1. Okay, so the next step is to divide by 1 or both of those. So let's use negative 4. Okay, we don't flip the sign because that is the 0. It's not the factor. We're not dividing by x plus 4. we know what the 0 is, so that's going to go in the box. And then my coefficients are 1, 3, -1, 9, and -12. I'm going to use synthetic division. You could totally do this with long division. If you did, you would divide this polynomial by x plus 4, the factor version of this. But for synthetic division, we can just put the 0 in the box. The 1 gets dropped down. 1 times -4 is -4. 3 plus -4 is -1. -1 times -4 is 4. -1 plus 4 is 3. 3 times -4 is -12. -3, and then I multiply that. I hope I get 12 because I should not get a remainder since I know this is one of the zeros. So my new equation becomes -3 constant, 3 is my x, -1 is my x squared, and x cubed. And now I have two choices. That looks like something I could factor by grouping, and I can. Or I've got another 0, I could divide by that. Let's do that. So I'm going to take my new equation, and if you like factoring better than dividing, go ahead, factor that by grouping. Or you can do division with the other 0 on your new equation. So the 1 comes down, 1 times 1 is 1, that's 0, 0 times 1 is 0, that's 3, 3 times 1 is 3. Again, I should get a remainder of 0. So 3 is my constant, 0 is my x, and 1 is my x squared. I don't need to write a 0x, so I've got x squared plus 3. So I've divided. Factoring, I don't really need to. I can solve for x now. X squared plus 3 equals 0. I can solve that just like I did on the last page. Subtract the 3. I get x squared equals -3. Square root both sides. Get x equals plus or minus the square root of -3. Be better to write it as I times the square root of 3 to signify that those two zeros are imaginary. So we got our two real zeros. Okay, so we've got -4, 1, and then we had two imaginary zeros. We did not see these on the graph. 4 zeros, x to the 4th. Okay, let's do one more. Okay. Again, 5 terms, so I can't factor it. Let's hope Desmos can help me. It can. I see 2 real zeros. That means I'm going to be looking for 2 imaginary zeros, but my 2 real ones are at -3 and 4. We can divide by either one of those. Let's do -3. My coefficients are 1, -3, -8, 22, and -24. Bring the 1 down. 1 times -3 is -3. That's -6. -6 times -3 is 18. 10 times -3 is -30. -8 times -3 is 24. No remainder. Shouldn't get a remainder. Okay. You could attempt to factor this by grouping, but I will tell you this one actually doesn't work. So if you can, it's kind of always a good idea to divide by the other 0 just to see what you get. But this one does not factor by grouping. So I'm going to bring it back down here. This is my only option. Use my new coefficients. Use the other 0. 1 times 4 is 4. It's -2. -2 times 4 is -8. And 2 times 4 is 8. So I'm left with something that I can't solve just by solving for x. And since it didn't factor by grouping, it's not going to factor by the AC method here. So my only option is to use the quadratic formula. So we do -b, so -2, plus or minus the square root of b squared, -2 squared, minus 4 times 1 times 2, that's my a and my c, all over 2 times 1. Negative becomes a +2. It's going to give me 4 minus 8. Bring it down here. So I've got 2 plus or minus the square root of negative 4 over 2. Okay, square root of 4 is 2. Square root of negative 4 is 2i. And I can divide that whole thing by 2, right? I can divide the 2 by 2 and the 2i by 2. That gives me 1 plus or minus 1i. So 1 plus I and 1 minus I are my imaginary zeros.